Good morning, my lovely students of St. Patrick's College, Germany. I'm your maths master, Mr. Lawrence. But we are here to look into what we have in our second week in our second week scheme of work. What we have there is geometrical theory. In this geometrical theory, we are going to look at two main things. One of them is what? Congruent triangle. First of all, we're going to ask ourselves, what is congruent? Look at it. Two figures are congruent if they have exactly the same shape and what size. Exactly, mind the word there, exactly the same shape and what? Size. Once two shape, for example, two triangles, once you bring the two, if they have exactly equal shape and size, which means they are what? Congruent triangle. Look at it. If you look at these two shapes now, they may look as if to say they are not the same. But if you bring this one and place it on top of this, and they are able to maintain exactly the same size and angles, which means that the two of them are what? Congruent triangle. Look at it here. The two triangles are congruent, although at first they may appear different. Like this one, the positioning are what? Different. But once you put two of them together, they will be able to give what? The same, they will have the same size and the same what? Angles. If one of the triangles were cut out and turned over, it could be what? Arranged to fit. This is fit exactly over the other. Then when such condition happens, which means that the two triangles are what? Congruent. Look at the things, the condition we have to look into. We have up to 4 conditions. The conditions are what? Conditions that make two triangles congruent are: number 1, we have two sides and included angles. We have side, angle, side. Side, angle, side. That is two sides and one angle. Look at this triangle. Triangle LMN and triangle XYZ. Look at this. LM is equal to what? XY. And MN is equal to YZ. The angle LMN is equal to angle at what? XYZ. So what are we talking about? In these two triangles, since this side is equal to this side is equal to this side, and this angle is equal to this angle, which means they are what? Congruent. That is what is explained here. Then the next one is this: two angles and a corresponding side. Two angles and a corresponding one side. If you use the abbreviation, it's going to be angle, side. AX, or it can be written as ASA. But what is there is that 2A must be there. And those A represent what? The angles. In that case, you see that this is the angle, this is the angle. This is angle, this is angle. This is 1, 1. So which means side EF is equal to JK. The angle at DE, angle at E is equal to angle at what? J. Angle at F is equal to angle at what? K. Once such a thing happens, it means that they are what? Congruent. Remember that in this triangle, this is triangle DEF. You will not come and say triangle JKH. No. If you say it that way, which means that they are no longer what? Congruent. Since this is what? DEF, Here should be what? HJF. Why is it like that? It is so because this is one of the angle, this is one of the angle, this is this side, this side. You start this and this, this and this and this. If you do not do it that way, which means they are not what? Congruent. And because of that, that was the reason why a distance from here to here is the same thing as what? Distance from here to here. But in this place, it is what? Angle, side, angle, condition. Let us keep on moving. Then, number 3. If you look at this one, this is 3 sides. In this type of triangle, 3 sides will be given to you. And look at this triangle. Triangle RXT. And triangle what? UVW. If you look at these sides, if you in triangle, the kind of triangle that has this kind of shape now is what they call scalene triangle. No sides is equal to each other, one another. So this one is 1, 1. So which means that RS is equal to what? UV. And ST is equal to what? VW. RT is equal to what? UW. So when you have such a case, it means that the two triangles are what? Congruent. The last one is what? Right angle, hypotenuse, and what? Side. Right angle, hypotenuse, and side. Right angle, hypotenuse, side, side. So in this triangle, you see that EFG is equal to what? KLM. Angle at what? The angle is what? Angle 90 degree. Then FG is equal to L what? M. And EG is equal to KM. So when such a case is established, which means that the two triangles are what? Congruent triangle. Remember what we said about congruence. When two triangles, they will have equal, the same angle, the same size. When you place two of them together, they will be what? The same. There will be no difference. Then the second part, I told you that we are going to look at 2 parts. We are through with the first part. This is second part. That second part now is the one we call parallelogram. Look at the shape of parallelogram. If you look at this shape now, see that AD is equal to what? BC. And AB is equal to DC. Look at 1, 1, 2, 2. These are the opposite sides. What are the properties? Properties of a parallelogram, which says that opposite sides are equal. Look at it. This and this. Opposite sides. This and this are also what? Equal. Then the opposite sides are what? Equal. Okay. The opposite angles are what? Equal. The diagonal bisect one another. What do I mean by diagonal? This one. These are the what? The diagonal. Then from this, it will help us to go into the one we call intercept theory. This parallelogram will lead us to what? The one we call intercept theory. So in that intercept theory, now it said that if 3 or more parallel lines cut off equal intersect on a transversal. Remember in your last lesson, I told you about transversals. When you have 2 parallel lines, you now have the transversal is one that cuts the 2 parallel lines, whereby you're going to get what they call corresponding angle, vertically opposite angle, alternate angles there. Then look at it here. We have this. If you look at this, see that you have 2 parallelogram here. Look at the 2 parallelogram. A, X, B, P. The next one now is what? B, Y, C, Q. Parallel, double, 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 double. Then from this one, the first one says AXPY, ASPB is a parallelogram. Then if it is a parallelogram, which means that XP is equal to what? AB. Then you see that AX is equal to what? BP. Then BY is equal to CQ. Under that condition, then you see we have two triangles here. Triangle XPY and triangle YQX. In these two triangles, look at the sides. XP is equal to what? YQ. Look at it here. XP is equal to what? YQ. And if it is so, which means that the angle at X1 should be equal to what? X2. And Y1 should be equal to what? Y2. Then, let us apply this thing in solving this example. Then look at this example. This is a parallelogram, like this and this. These are three parallel lines. Then we are now to find the letters. What are the letters? The letters are what? X, Z, W, Y. Then here is what? 8 cm. Then if 8 cm is here, which means our Z should be 8 cm and Y it should be what? X cm. Look at it. Z is equal to Y is equal to 8 C. Let me put cm. Then this one is 6. 6 is here. W should be what? 6. W should be 6 cm. Because this side, the distance from here to here and from here to here, they are what? Equal. They are parallel what? Lines. In that case, if here is 6 cm, here should be what? 6 cm. Then this is equal to this is equal to this. Then what about X? If this distance and this distance, they are what? Equal. Which means that X is 5, S is 5, which 5 cm is here. S is also what? 5. So in this case, I want to tell you that in this geometrical theory, the first one, in summary, we talked about the congruent triangle of which I told you that congruent now, the meaning of congruent now means that two triangle or any shape whereby they have equal distance, equal angle, it means that they are what? Congruent. There's no difference between the two. You see that the two are what? Congruent triangle. We also have the conditions. It can be side angle or side or angle side, or right angle hypotenuse and side. In that case, we see parallelogram. Their properties from there that are used to derive intercept theories, which are very, very simple. Look at it here. You just apply this, the simple solution. When you go to your mathematics, you're going to see so many examples. So you have to solve. The more you are solving, the more you are learning. Thank you. and wait for another class.